Let's get started with lesson 3.6. Lesson 3.6 deals with congruent triangles. Our objective is to explore triangle types and introduce methods for copying triangles. I want you to take a look at the triangles on this page, and you'll notice some little lines on each of the triangles. You see a line, a 1 hash mark, 2, 3. Same thing over here. The hash marks are going to be important in a little bit, but I just want you to see these two triangles and what do you notice about the triangles. So as we're going, and how do we figure out what the word congruent means, and how do we know if the sides are equal, not equal, and we're going to find that out. But let's do a little mental math first as a warm-up. It says round each number to the nearest tenth. Little review. So if I have 81.39, hopefully I know that my tenths place is the 3. So in order to measure that, in order to round that, I'm going to look at my 9 here, which is in the hundredths place. So I'm going to look at my 9, and my 9 is in the hundredths, and I know that it is greater than 5, so I'm going to round my number up, and hopefully you decided and said that this number should be 81.4. And I'm going to write it up here because I have so many places. Oops, I apologize, that's not so good. I need to erase. Oops, I need to erase my mess here. Does not want to switch gears. I think my marker is running out of ink. So let me try it over here. Oh, here's my eraser. Okay. Come on, eraser. There we go. I think I'm running out of juice on my airliner. So 81.4 is what I would have put. So let's move on to the next one. And let's see what we have here. So we have 376.14. So again, 376 and 14 hundredths. So I have a 1 here. I have a 4. I know the rule has to be 5 or higher to change it. So I'm going to leave it at 376.1. And I hope that's what you would have done also. 546.69. Again, 546 and 69 hundredths. I'm going to look at my 9. On my 9 here, I know that it's 5 or higher, so my new number should be written as 546.7. 546.7. And again, hopefully that made a little bit of sense to you. All right, moving on, our last one. 43.247, or 43 and 247 thousandths. Again, the 7 doesn't mean anything over here in the thousands because I'm rounding to the tenths place. So again, I look at my 4. It is less than 5. So I'm going to leave it as 43.2. So again, good practice, good review. So let's keep moving on with our congruent triangles and knowing if they are. So this is our math message. It says, use only the information on the page to complete the problems. It says there are marks or small marks on the sides of the figures below. These marks show sides that are the same length. So again, I said those little hash marks were going to come in handy in a little bit. So it says it shows them. For example, in the first triangle, under equilateral triangles, all sides have 2 marks. These sides are the same length. So if they all have the same number of marks, it means that they're the same. For each type of triangle below, study examples and non-examples, then write your own definitions. It says do not use your student reference book. We won't need to use it. Notice how there is a different hash mark on each side of this triangle, and all the numbers here are different. So what is your definition of an equilateral triangle after seeing this and this? I hope you would have said that an equilateral triangle means all sides are equal. So I would write, oops, and my eraser is on, sorry. I would write all sides are equal. Are equal. And another thing to know is that all angles are equal too. And the angles would all be the same in an equilateral triangle. Now, one thing we do know about triangles is they all total 180 degrees. So in an equilateral triangle, they would all equal 60, because 60 times 3 would give me 180. So moving right along here, the isosceles triangle. Now, I noticed that This side has 2 hash marks and this side has 2, but the bottom only has 1. If I look at my number, 7, 7, 12, 2, 2, 1, 2, 2, 2. Okay, over here, 4, 3, 5, 11, 13, 12. Okay, 3, 2, 1. So what is the definition of isosceles triangle? If you notice on an isosceles triangle, I hope you noticed that at least 2 sides are equal, and that is the definition. And so it's at least 2 sides are equal. So we'll go down here, sides are equal. Oh, it switched colors on me. So there we go. And our last triangle then is called the scalene triangle. And hopefully this word may sound familiar. But if I look, I see 3, 2, 1, 2, 1.5, 2.25, 15, 16, 4. And then if I look over here, I see 2, 2, 2, 8, 8, 8, 2, 2, 1. So in a scalene triangle, hopefully you, by looking at it, know now that in a scalene triangle, no sides are equal. So no sides are equal. And I'm using the whole thing here. I apologize because my clear liner is kind of acting goofy, and maybe me, Mrs. Heath, is having a hard time operating it either. But no sides are equal, so that would also mean none of the angles are equal. So let's move on. And it says equilateral triangle, isosceles triangle, and scalene triangle. And if I look down here, I have no sides are the same length, 2 sides are the same length, or 3 sides are the same length. I also have 1, 2, 3 triangles. So let's see if we can figure out where those would belong. Well, no sides are the same length. I need to scroll up because I know that in a triangle where no sides are the same length, that would be a scalene triangle. So I'm going to put my definition over here. Okay, now I know equilateral also means equal, so I know that that means all of the sides in the triangle are the same. So therefore that is 3 sides are the same length. So I'm going to put that there. And finally, an isosceles triangle tells me that 2 sides are the same length. So I'm going to move that definition here. I also have a triangle that measures each of them or goes with each definition. If I look down here, I know that my big blue triangle here is equal. So I'm going to move it right here. Oops, it doesn't want to move. So I'm going to move it right there. I know that this side and this side, or this side and this side, are equal. I know at least 2 sides are equal here, so I'm going to put that here. Now if I look at this side, it's short. This side is a little longer, but this one is really different. So I know in this case, none of them are the same. So I have an equilateral, all sides are the same. I have an isosceles where at least 2 sides are the same. And I have a scalene where none of the sides are equal. So it gives us our little definitions to match, and hopefully that makes sense to you, knowing the definitions of those 3 kinds of triangles. Finally, let's wrap up with this. It says creating a congruent triangle. If 2 sides are identical, exactly the same size and the shape, same size and shape, they are congruent to each other. Congruent triangles would match perfectly if you could move one on top of the other. So that's exactly what it means. It means that exactly if 2 triangles are identical, exactly the same size and shape, they're congruent, meaning all the sides are the same. I could set this triangle here on top of a triangle that looks identical to it, and they're congruent. Let's make a copy of triangle big on a blank sheet of paper. Use any of your drawing and measuring tools, but do not trace triangle big. The sides of triangle big, the angles also. Make sure you copy the sides you copy of your copy should be the same length as the sides you draw, and the angles should also be the same size. So we can't trace it. So what are we going to do? We do have a compass that might come in handy. We also have a protractor. So what could we do? So then it says, when you are satisfied with your work, cut it out and tape it in the space below. Label it PAL. Triangle PAL should be congruent to BIG. So I'm going to tape it. If I tape it right on top of here, it should be identical. They should match up perfectly. So in class, we're actually going to practice drawing or copying the triangle BIG. We're going to use our compass and we're going to make some line segments, and we are going to actually make a congruent triangle in which the angles will be the same and the sides will be the same. So again, practice, and we can use our compass, or we can use our protractor as a straight edge too. Remember, has that nice straight side in which we can use to draw line segments. Doesn't mean we're measuring it, it means we're using it as a straight edge. And there is a difference. So lots for us to do in class. I do want you to think about the difference between the three types of triangles and write a definition now of what a congruent means, okay? And be able to tell me in class what is equilateral, isosceles, and skinny lean. Let's go back to our first page and to our objective. It says to explore triangle types and introduce the methods for copying triangles. And we are going to talk about that in class, but we did do that. And we will talk again about congruent triangles. Nice job. Remember to complete the quiz.